Alright, in this video we're looking at this complicated equation and trying to find its intercepts and to test it for symmetry. So let's start with the intercepts. You would want to create a table first, x and y, and then in the table you'll let x be 0 to find the y-intercept, and then you'll let y be 0 to find the x-intercept. So let's start with letting x be equal to 0. So y is equal to 0 to the 4th power plus 2 over 2 times 0 squared. Well, the problem with that is that 2 times 0 squared is going to give you 0 in the denominator, correct? And that would make the whole expression then undefined, right? So you can't have a y-intercept if the resulting equation ends up becoming undefined. So at this point, we'll just kind of cross that out and say, okay, that's not possible, right? It's not possible to, in this case, let x be equal to 0. Okay, let's go ahead and see what happens when we let y be equal to 0. So when we let y equal to 0, we're going to end up having x to the 4th plus 2 over 2x squared. Now, this is a fraction, right, or a rational expression. And the only way a rational expression is going to have a value of 0 is if its numerator is 0. That would have to mean that x to the 4th plus 2 is equal to 0. But this can't be, because if you subtract 2 from both sides of the equation to try to solve for x, you're going to see that we get a statement that says x to the 4th is equal to negative 2. There are no real number values that are going to show up in our graph that have the property that when you raise them to the 4th power, they give you a negative number, right? Whenever you raise something to the 4th power, the answer has to be an even number. So for example, if you took negative 1 and raised it to the 4th power, that's the same as having negative 1 times negative 1 times negative 1 times negative 1. And of course, every pair of negatives is going to cancel out to a positive, and you just end up with plus 1 times plus 1, so the answer is just 1. So of course, anything to the 4th power is going to have to produce a positive answer. So there's no way you'll find a real number that raised to the 4th power gives you negative 2. So if that's the case, we don't have an x-intercept either. So at this point, we're going to go ahead and say that there are no intercepts for the equation. That means the equation does not cross either axis. Okay, so now that we know the equation doesn't cross either axis and we have no intercepts, the next step of the process is going to be to test the equation for symmetry. All right, so let's test the equation for x-axis symmetry. In order to test the equation for x-axis symmetry, we have to set y to negative y and see if we can simplify the equation back to the original equation we started with. If we can't, then we'll say the symmetry does not exist. So I don't see how we can get rid of that negative in front of the y now without changing the equation in some way. So basically the equation has changed. Putting in negative for y doesn't work. So I'm just going to say, okay, no x-axis symmetry. So no x-axis symmetry. Okay, let's go ahead and test it for y-axis symmetry. For y-axis symmetry, we set the x negative and see if everything stays the same. So y is equal to negative x raised to the 4th power plus 2 over 2 times negative x raised to the 2nd power. Well, as we discussed a moment ago, when you raise something to an even power, like negative x to the 4th power, it just becomes x to the 4th because the negative sign will, of course, disappear and become positive. And then we'll have plus 2 after that, and then we'll have 2 times negative x squared. So, of course, that's the same as saying just x squared, because squaring the negative is going to make it positive. So ultimately we end up with the same equation, and that implies that it does indeed have y-axis symmetry. So I'm going to put a little check mark here saying yes, it has y-axis symmetry. Alright, let's test for the last one. The last one is origin symmetry. I'm just going to do it up here. For origin symmetry, we're basically going to set y negative, set x negative, and see if the equation remains the same. I think it's not going to, though, because I don't see how we're going to get rid of the negative on the y, but let's do it anyways just to see what happens. So again, what's going to happen here is we're going to end up having negative y is equal to, and like we said before, the negative x's are going to become positive x's because the even exponents that are on those terms. So that means that the right-hand side of the equation doesn't change, but the left-hand side has. Since we can't get rid of that negative there, this fails to have origin symmetry. So I'm just going to say, hey, there's no origin symmetry. So there is y-axis symmetry, but there is not x-axis or origin symmetry. So for this problem, we're simply going to say that there's y-axis symmetry, but there is no x-axis symmetry, no origin symmetry, and we do not have any intercepts.